Have you ever turned on your tap for a glass of water and just trusted it? Yeah, we all do. But behind that simple, everyday act, there's this incredible high-tech battle being waged against a whole world of invisible threats. So today, we're going to pull back the curtain on the hidden guardian that keeps our waters safe. Okay, just take a look at this. I know, it kind of looks like some weird futuristic maze, right? But what you're actually seeing is a huge water treatment facility. This is where some of the most advanced purification technology on the entire planet is working around the clock, 24/7. And that really is the big question, isn't it? I mean, if the water coming into a place like this often looks pretty clear, what is all this massive infrastructure actually fighting against? Well, the answer's pretty simple. The biggest dangers are the ones you can't see at all. We're going way beyond just a little bit of dirt or cloudiness. We're diving deep into the microscopic battlefield that's happening inside our water. I mean, we're talking about this microscopic soup of stuff. You've got bacteria, viruses, and these really tough parasites like Giardia and Cryptosporidium. And on top of that, you have dissolved chemicals like arsenic and other nasty organic compounds. You know that basic sand filter you made in science class? Yeah, that's just not going to cut it against these tiny, dangerous intruders. So, how in the world do you fight an invisible enemy? Well, you build a much, much better gatekeeper. And this is where a truly revolutionary technology comes into play: membrane filtration. It is an absolute game changer in water purification. Now, what's so cool about this is just how different the approach is. See, old school filtration is kind of like a complicated maze. It hopes to trap particles as they wander through. But membrane filtration? It's not a maze. It's a wall. It is an absolute physical barrier with these perfectly engineered little holes, or pores. And the rule is simple. If a contaminant is bigger than the hole, it does not get through. End of story. This technology really works on 4 main levels, and each one gets more and more powerful. First up is microfiltration. I want you to think of this as the bouncer at a club. Its pores are about zero point 0.1 microns, so it's like a super fine screen that physically blocks the bigger microscopic troublemakers, like bacteria and protozoa. Then we step it up a notch to ultrafiltration, and this is where things get even tighter. The pores here shrink by 10 times, down to just 0.01 microns. At this scale, the barrier becomes so incredibly fine that even tiny little viruses are stopped dead in their tracks. Okay, now things get really fascinating. With nanofiltration, we're talking about pores that are just 0.001 microns wide. We've actually moved beyond just blocking physical particles. At this scale, the filter can start pulling out stuff that's actually dissolved in the water, things like certain organic molecules. And that brings us to the ultimate guardian, reverse osmosis, or RO. The pores here are an almost unbelievably small 0.0001 microns. This is so fine, so precise, that the filter can do something that sounds like it's straight out of science fiction. It can physically pull individual salt ions out of seawater, turning ocean water into fresh, pure drinking water. So, the big question is, how on earth do you force water through a barrier that can stop a single ion? Well, to do that, you have to fight back against one of nature's most basic processes. You see, in nature, water is always trying to find balance. It's a process called osmosis. If you have salty water on one side of a membrane and fresh water on the other, the fresh water will naturally flow towards the salty side to try and dilute it and even things out. But of course, our goal is the exact opposite. We want pure water, not just more diluted dirty water. So we literally reverse it. We use these powerful pumps to apply a ton of pressure to the contaminated side. This pressure completely overwhelms that natural tendency, and it literally squeezes the pure water molecules through the membrane's tiny pores, leaving all the salts, minerals, and other contaminants behind. Now, this technology sounds almost perfect, doesn't it? But there's a really obvious practical problem. If your filter is this good at catching everything, how do you stop it from getting completely clogged up? Yeah, keeping these filters working is a whole science in itself, a process that's just as clever as the filtration. It's basically a 3-step dance. First, you get a quick reverse flow of clean water, which is kind of like a rinse cycle, just to push the loose stuff off the surface. Then an air scrub shoots bubbles through the system that shake everything up and knock off the more stubborn bits. And finally, every once in a while, a chemical clean acts like a deep clean to dissolve the absolute toughest buildup. So why does all this complex engineering really matter? I mean, what's the big deal? Well, its impact on our health and our ability to manage the planet's water is just absolutely massive. Just look at this number, 99.9%. That isn't just some marketing slogan, it's a certified promise of safety. What it means is for every 1,000 nasty parasites like Giardia that go in one side of the filter, maybe one gets through to the other side. That is an incredible, life-saving standard of protection. And the real-world applications are just huge. We're talking about making fresh drinking water from the ocean for places that are in a drought. It's a non-negotiable physical barrier against diseases. It reliably pulls out dangerous chemicals like arsenic. And it helps our local water utilities meet and often exceed the really strict safety standards that are there to protect all of us. So the next time you take a drink of water, just take a second to remember that invisible guardian that's at work. This incredibly sophisticated, powerful technology that's standing as our last line of defense. And it really leaves us with a final thought. As our planet faces bigger and bigger challenges with water, could this invisible technology be the single most important tool we have for a healthy future?